Hello there. My name is David Clemens Sewall, and I'm a graduate student researcher at the Thayer School of Engineering at Dartmouth College. I'm excited to be working with you this year as part of the SEPA project, and I thought I'd take a minute in this video and introduce myself to you. So I grew up attending public school in Pittsburgh, Pennsylvania, and I thought it might be fun if I share with you the very first science experiment that I remember doing. This was in Mr. Mean's 5th grade classroom, and he asked us to predict that if we took a dime and we were to add drops of water to it, to predict how many drops we could add on the dime before the water would just pour off the side and land on this paper towel. And as a 5th grader, I think I probably predicted 1 or 2, if that. So let's give this a try. 1, 2, 3, 4, 5, 6, 7, 9, 10. We're a lot before 1 or 2, or a lot more than 1 or 2. 12, 13, 14, 15. 16. Okay. So 16 drops there, and you can maybe see the reason that as a 5th grader I didn't know why this would work is something called surface tension, which you may have learned about already in class, or you may learn about sometime in the future. And this is sort of a simple little example, but it highlights a lot of things that I really like about science, where you take some process, something that's out in the world that you don't know about, in this case for me, how many drops I could add to that dime, and then you design an experiment to go out and learn more about it. So I think of science as really just an incredible journey of exploration that I enjoy going on, and I'm excited to share with you all this year. Now, my research now is a little bit different. Instead of predicting how many drops of water we could add before it collapses off a dime, I seek to predict the future of climate change. Events like the extreme flooding we sometimes get in New Hampshire and Vermont, or the wildfires that many of you have heard of out west, are caused in part by global changes in our planet's climate. These changes are happening all across the planet, and what happens in one part of the world affects what happens in the rest of the world. One area that in particular has seen a lot of changes in the last few decades are the polar regions. When I say polar regions, the screen share will work. What I mean is Antarctica, shown here, and the Arctic. This is up to the north of where we live down here in North America. And so to study the changes that are happening in these polar regions, I actually travel out there. So I go out into the field in places like here. This is up in the middle of the Arctic sea ice. And I study in a lot of detail what is happening to the snow and ice there. I use modern technologies to do this. For example, this is a terrestrial laser scanner. It basically shoots out pulses of laser light and then measures the snow surface at a really high resolution. And using these data, I can then put together an understanding of what's changing in these regions, how is climate change affecting them, how might they affect climate change elsewhere, and really build a better understanding to help us predict and adapt to what the future will be. I also thought it might be fun to share with you a couple animations that we can make using these data. So this is an example where, like I said, I use the laser to go out and measure the snow surface at very high resolution. And from that, we can generate examples like imagining we were flying across the snow surface, like in this one. Or, for example, imagining we were circling around a point out here in the pressure ridges. So this is just a short introduction to who I am and what I do. But I hope something here has caught your interest, and I look forward to working with you all throughout this year.